Today I want to talk about a very common type of boiler, one that many people are still using every day. But it's also a type of boiler where just a small moment of negligence can lead to very serious consequences. That is the belly-fired boiler. With over 15 years in the boiler industry, I've worked on everything from design and manufacturing to installation, operation, and troubleshooting on a wide range of systems. Fire tube/water tube combination boilers, single and double drum water tube systems. One key lesson I've learned: boilers aren't dangerous when new. Boilers are most dangerous after long periods of operation, when operators become familiar, start to grow careless, and gradually forget their training. The belly-fired boiler is a typical example of this. What is a belly-fired boiler? Simply put, this is a boiler where the flame burns directly beneath the bottom of a large steam drum. That means the pressurized steam drum is above. The flame is directly below. Advantages of belly-fired boilers. I have to admit, this is a very compact design. Compact in width, height, length. It is very suitable for limited installation space, long-distance transportation, high calorific value fuels. For export, logistics costs are also lower thanks to the compact size. I used to really like this type of boiler. In my early years, I personally installed many belly-fired boilers. And I also experienced quite a few failures with them. There was a belly-fired boiler from another company that I was called in to inspect. When we opened it up, the bottom of the steam drum was already bulging. I told the factory owner directly, if you had discovered this a bit later, you wouldn't be repairing the boiler. You would be dealing with an explosion. After that incident, I stopped developing this type of boiler, especially under real operating conditions in Vietnam. What is the root cause? The answer is scale buildup. If the boiler has poor blowdown design, improper or inconsistent blowdown operation, inadequate water treatment, no proper control of pH, TDS, and hardness, then in a short time, scale will form at the bottom inside the steam drum. If strong fire continues beneath that area, the drum wall cannot dissipate heat, steel temperature rises significantly. While internal pressure remains high, the risk is obvious. What you are seeing here is a bulging steam drum. Fortunately, it has not exploded. Can this risk be eliminated? The answer is yes, but it requires one key thing: strict operational discipline. Specifically, perform regular blowdown based on TDS levels. Use proper water treatment chemicals consistently. Keep pH, TDS, and hardness within allowable limits. These are the water quality parameters that must be controlled for industrial boilers. Periodically inspect inside the steam drum. Weekly, monthly, quarterly. If the drum bottom stays clean, then you can operate safely. But if you become careless, are overconfident, leave everything to operators without supervision, then the hidden risk becomes extremely serious. Today, many factories are still using belly-fired boilers. That's why I made this video. I want you to check your boiler, starting today. Right now, go back to your plant and ask your operator these 3 questions. When was the last blowdown performed? When was the last internal drum inspection? What are the current pH, TDS, and hardness levels? Are they within allowable limits? What are those limits? If they cannot answer, you are facing a serious risk. I hope this video helps you better understand belly-fired boilers. If you find it useful, please like and share so that safety knowledge can spread further. Thank you for watching.